To get a full experience of debugging and fixing a security bug, we should be able to run, test, debug, and fix the security bug locally on our workstation using our own favorite tools or IDE. Effectively, solving a SecDim play challenge is like debugging a normal app. And in this guide, I will show you how to set up your local workstation to run and test challenges, and later on you can fix and push the code. We can run the challenges either inside the container or on our host, and by host I mean the operating system that we may be using: Linux, OS X, and Windows. With regards to Windows, firstly we should run a Linux virtual machine, or in this case an Ubuntu desktop virtual machine, and later you can follow along the commands that I run as part of this guide. By running the challenges in the container, all the required dependencies are given to us. If we decide to run it on our host, we just need to manually install the dependencies for the app and then later follow along to debug the app. Let's just go through one example. JavaScript setup.js. If you scroll down a bit, you will see a bash script. To prepare our workstation, firstly, we need to add our SSH public key to our SecDim account. Now, SSH is used to clone that Git repository from the remote server to our workstation. Secondly, we need three basic tools: Git, Make, and Docker. Git and Make normally is given in the majority of the Linux distributions, so we don't need to install them. We only need to install Docker, similar with the OS X. Now, this bash script that I have highlighted here will do all these things for us. Copy that, open a terminal, and run it. Firstly, it will ask if you have registered. We press yes. Have you added your SSH publicly? I will say no. Have I signed in using GitHub or GitLab? If you have signed in using GitHub and GitLab, you may need to add your SSH publicly manually, because this script will not be able to add it automatically to your account. For that, I assume you have already signed in. Click on the user menu and click on account settings, login. Now in this case, I'm logging in normally. For your case, you want to log in, sign in using GitHub or GitLab. Click SSH key, add or update SSH key, and follow along this simple instruction to add your default SSH public key. Let's go back to the terminal. Here I would say no. Now, what the script just did, it has generated a pair of default SSH key, ID underline RSA. Now, if you have already an existing default pair of SSH key, the script will reuse that. And the next thing it will ask is our SecDim username and password. So it would be able to upload this SSH publicly to our account. The next thing it will do, it will check if SSH connection is successful. If that's so, that means we would be able to use Git to clone the repositories. And finally, it will go through checking if we have those tools: Git, Make, and Docker. If you already have them, the tool will not reinstall them. Otherwise, it will attempt to install them. All done. If you have seen setup is successfully completed, that means you're all good to go. Let's head back to the challenge. Scroll up. Play. Let's do this. This time, I'm not gonna use the browser. I'm gonna hit clone. Copy this Git URL. Go back to the terminal. type in git clone and paste that git URL here. In a few seconds, that repository, that challenge source code is being copied locally for you, and I have all the codes now available on my local workstation. From here on, you can open up your favorite IDE. In this case, I opened up Visual Studio Code, and I have access to all the source code. I'm gonna try now run this challenge using the container, which is the simplest way. Open a terminal, type make build. This make build will go and build the container image on our workstation, so we will be able to run the app. Inside the container, all the tools dependencies are already provided, so we can simply just run it, test it, and debug it. Make test will run the usability or functionality test. If you don't know what these functionality or security tests are, maybe you want to have a look at my previous guide. To run the security tests, we type in make security test. Now, as you remember, usability test by default will pass anytime we have been given the Git repository of the challenge. Security test will not. Now, security tests are an example of an attacker's payload that will be executed against our program. And let's now run the program. In this case, we have a node, a web application. It's now listening on port 8080. If you open a new terminal, we can communicate with that. 8080. This is a response come from the server. We can also open this program inside our browser. Let's go back here, open a new tab. And we can see that the program responds. Before I dive into the code, let me just go through a few more commands here. Let's open the main program and let's just make a sample change. Just add a comment, sample comment here. Save this. If you now run make push, this is a shortcut for git add, git commit, git push. It sends all these changes that we done to our local repository to the remote repository, and then once that is done, the server testing will kick off. So done, check out the challenge commit page. If you go back here, as you can see, the server testing is started. Now, one of my favorite command is make a status. If you run this command, it will go and fetch the challenge status and the test output from the server without the need for you to context switch to the browser. So now I can see this is a remaining time for this challenge. The result of the server testing is failed, and also I can see the test output, that why these tests failed. Another really good command is make debug. So anytime we make changes to the file just to see if we manage to fix the security issue, we should always run make security test. This will rebuild the container image with the changes that we have already done, and it will run the security test. Now, another command is make debug. This command will gives you a shell from the container. So while you are doing changes to the code here, all these changes will be reflected inside the container. In this case, as you can see, the changes that I just did on my ID now is reflected in a container. And now I can just run, in this case, npm command, because I'm dealing with a node program, and run the test, or even run the security test, or even run the app. So if you are a JavaScript developer, you will know these npm commands. And you can run this as if you have installed these tools on your host. So you can use make debug to just speed up your debugging process. All right, with that, let's go and read usability test for this challenge. we have two sets of tests. We have two tests. The first test will check if the program returns 200 anytime we send a request to root. So you can see here. The second test will check if we send a request to root, the program will contain the name value. So it receives a query parameter name with the value Alice, and it expects to see Alice in the response. It's a good time to look at the main code. Again, it's Express code. And if we head down to the main function, very easy. The root will return 200 with hello, following with the query parameter name, whatever you enter in the address bar. So let's just run this program to verify this. Make run. And if I now use curl, or let's just use the browser in this case, and provide a parameter called name and SecDim. Well, I can see SecDim here. So what can go wrong with this coding pattern? So anytime I enter something as an input, it's being echoed back. Perhaps let's look at the security tests to give us some hints around what could possibly go wrong here. Security test, it expects to receive an escaped HTML in the response anytime there is a XSS payload. So what is XSS? XSS is abbreviation for cross-site scripting, a known bug that happening a lot on web applications. And an example of what an attacker can possibly send to the program is given here. So instead of entering Alice, if the attacker entered this script tag with this JavaScript function alert, the program, well, let's just give it a try, see what happens. If I just give that to the program, just make sure the program is running. Now go back here, instead of name, let's just pop this in. Well, that JavaScript code or that alert function got executed. Now, I will leave it as an exercise for you to figure out what else an attacker can do in this case, but the fact that attacker is able to execute arbitrary code could lead to a number of compromise against our user base. So the next nice thing about this security test is that not only we have been given an example of an attacker payload, also it will expecting a right behavior or right preventative measure for us to address this security issue. In this case, the security test expect the program to escape or HTML encode these special characters. So less than sign should be converted to this. And by doing so, that JavaScript pop-out that we just saw will not get executed. The other thing we can read from this test is this CWE79. This is a reference to a definition of this security bug. So if you just search for this CWE, you're gonna come up with this page, and you can read more about what and what not is possible using this cross-site scripting or XSS attack. Okay, let's head back to the main code. Now we know what we need to fix, and let's fix the program. So what I need is effectively convert those dangerous characters or bad characters to a HTML encoded version. If you open up the README, an example function is given to you. Let's copy that, and this function, let me first copy it here. Now this function receives a string, and it will look inside that string and tries to do that conversion. So if it says the less than sign, it will convert it with that, bigger than sign with that. And these are the minimum conversion to do to prevent this example of cross-site scripting. And so once we did this change, let's just call this function. So the place that where this information is being displayed or this data being displayed, I need to call this function escape HTML. And let's save it. And let's run the test again. I always first run the usability test just to make sure I haven't broken anything, and following with the security test. If I have done everything right, this security test should pass. As we can see, it has passed. Before I push these changes to get the score, let's just see what the program now does. So if I run it and refresh this page with the same payload, this time, as you can see, that alert will not pop out, because if we look at the page source, all these dangerous or unsafe characters has been converted to the safe encoded HTML equivalent. Now is the time for us to run make push. And let's go back to the browser and look at the test. This time I expect all these tests to pass. And that's all.